Good morning, friends. Actually, in the first part, we have seen the why WM is required and how much it is advanced. Advanced to and having an advantage over the IM, and what is its importance and where it is used, and actually where it is used. Actually, I will explain in my coming warehouse management videos, and I have explained the application of WM and then application of inbound processing, outbound processing, and then cross docking everything, and we can see one by one in coming videos. And in this second part of video of WM, I like to concentrate on SAP WM configuration, and all these things can be done in, as already know, it is done in SPRO. There is SPRO screen, and actually I already told actually the plant and storage location, and we in that actually we are defining and we are assigning the warehouse, and actually then it is called as a WM activated storage location or a plant, whatever it may be. And after that actually in logistic we have a node in SPRO called logistic execution, and then below that we have warehouse management, and below that we have a master data, and in that actually we have defined control parameters for warehouse. It is a node. So in that actually we are defining what is the exact warehouse number, and in case of standard SAP package, that is IDES package or something, we have 001 defined for warehouse Germany location. 001 is a standard one. Normally while you are doing any implementation, we will copy the warehouse from the standard 001 and create our own warehouse. It's a full warehouse, okay. And so say for example, in defined control parameters we are defining the unit of measure. What is the basic unit of measure? What is the capacity check required? And what is that, say for example, the storage unit management is activated or not, and updating that mail intimation to the user. It is an R2 warehouse, something, some different settings and fields are there available. And the and now actually now we have the question. We have in material master we have the unit of measurement, and then that is a basic unit of measurement, alternative unit of measurement, and here also we have the unit of measure. So which will have a importance, and which will override which one. So as in standard SAP, actually the unit of measure, basic unit of measure defined in the material will have the importance. And if in case actually the unit of measure is not maintained in the material master, then actually it will check for the control parameters for the warehouse. And if anything actually, say for example, if it is defined at a client level, that client level basic unit data one, that in material master will have a more importance compared to any other configuration. So please keep it in your mind, and this is very important. And next actually we need to define the same master data node. We need to define the number ranges for TR, TO, post change notice, everything for all the documents created in the warehouse. And the second thing, we need to define the storage type. As I already know, the below the warehouse number we have the storage type, and then storage section, and then storage bin. Actually for storage section we have parallelly picking errors, define picking errors. Why it is used mainly when in some cases we have the same storage section and picking area same, or sometimes in some other warehouses actually the numbering range will be different for identification purpose. Say for example, during put away they are using 001 storage section, and during picking they will use 002 picking area. So in order just to differentiate, it will help the user to understand what is the exact operation done, and there is no business logic or that, but it's for business user to understand the process. We can track whether it is a picking or put away, at what location it is there. From different thing actually. One more thing I like to tell, actually, when if you are using only storage type, you cannot track the exact material. You can track, but actually it will take time. But here actually within the warehouse we have different levels, so that material can be easily tracked at what time, what level and everything can be determined. So this is one of the important thing, and we have different transaction or reports for determining where the material is actually situated, which storage type, which bin, which section, everything can be determined. So as a, and the second thing, actually, I mean, next step is defining doors. Defining doors means actually why we need door. Actually, during once that during the loading or unloading of material in the warehouse entrance, actually we have different lane, and in near to that we have different doors. So the warehouse person in the entry point, so or as a kind of security, he will inform that warehouse supervisor or a manager, so which door or which gate to be opened for the incoming truck for unloading or outgoing truck for after loading and sent to customer, so which the door to be assigned, so that we can try make use of till that point of entrance in warehouse. I mean, not only inside warehouse, outside warehouse, at the point of gate also we can able to track the material where it is going and which door they are using. Through that, actually the vehicle, the truck is moving, everything can be determined. So in some cases, actually that gate the, I mean, they will segregate the gate based on the material type or material in the characteristics, everything. See, case of acid and all, actually we cannot use a gate which are more populated with I mean, more, which is having more population, and I mean, nearby schools are there. In that case, actually, we cannot use that gate. So we need to use a gate that is not having, I mean, human population is not concentrated. In that case, only we can able to move. These are the main reasons I'm telling. These are design criteria, warehouse design criteria. Okay, and then defining material staging areas. So staging area is nothing but actually it's a temporary location before doing picking and all. Actually, we need to stage a material in a temporary location, and once it processing everything done and the TO is confirmed everything, from staging area that will be sent to a final location for picking, or it may be a put away or whatever thing. So that is very important use of material staging areas, temporary location. And then actually we need to define the storage bin. Here only I told actually the barrow, the bin structure, everything can be determined on x y z coordinate. So it's a three dimension coordinate. Here we are defining the storage bin type, what is the exact type of storage bin, and then we need to whether the particular bin can be blocked for particular reasons. In standard we have blocking reason 1 and blocking reason 2. So that will help us to say for example, that will help us to block a particular bin during the physical inventory, or some, if bin is damaged, right? In that case, actually we can set a indicator b1 or b2, so that actually we can stop the material put away or material picking from that particular bin. These are the main advantage. And third thing, we can define the storage bin structure, as already told, actually the bin structure. And next comes material. So material, if material in the sense, actually we need to define the storage type indicator, and then there's nothing but actually the tool which is used for identifying the destination bin from the source bin when moving the material for put away, or it is when it is a picking from the source bin to the destination bin. So these are the important thing of storage type indicator. And then actually next come define storage unit types. Say for example, if we have storage unit management is activated in the warehouse, then we need storage unit types. And then actually we have defining the storage section indicators. When actually we have three types of indicator, hierarchy of indicators already told. We have the storage type indicator, storage section indicator, and then storage unit type indicators are there, and the storage bin indicators are there. So these are the levels of levels through which a material is crossing and it is moving, taken through the final bin. So then actually we have the special movement types. And then if it, say for example, if in case of food industry or pharma industry, we need to handle the material in batches, bulk storage indicators. So bulk storage area, bulk storage storages. So we need to activate the bulk storage indicators. So for here actually these are the master data point of view, and here I like to tell you that how the material is taken once material is coming to the warehouse gate. Say warehouse for put away. First once a material master is created, so the system will check first. Say for example, sorry to give wrong information. Actually once the TO is created, and before confirming the TO, the system will check the will go to the material master first, and it will check whether the warehouse 1 and warehouse 2 data is maintained or not. And in warehouse 1 we have the storage stock removal indicators and stock placement indicators, storage suction indicators, bulk storage indicators. All these things are defined, and based on the indicate, that is the stock placement and stock removal indicators, it will decide whether it is a put away or it is a picking purpose. And if stock placement indicator is set, then it will say for example, if it is a stock placement operation, it will check for stock placement indicator, and the picking in the sense stock removal indicator will get checked, and then the storage suction indicator will get checked. And if the particular material is activated with the bulk strategy, then actually we have the bulk storage indicators mentioned in the material master warehouse 1 view. So first check will be a material master, and the second check will the system will check the uh, say for example, the indicators we are using. First we'll check the storage type indicator set in the configurations pro screen, and the second thing it will go for a storage suction indicator defined, and then third thing it will go for storage bin type indicators and storage unit type indicators defined. So say for example, now actually say let's say actually we have 10 10 to 30 different storage types are there, and these materials can be placed in different storage type. We cannot determine which bin to be checked for by the system for the first time when it is checking some X material. In that case actually we need to avoid this confusion by setting this by using this storage type indicators. Actually it is nothing but actually we are grouping all these 10 to 30 storage type under the storage type indicators, so that system will check the storage indicator. And in configuration we have the storage type search sequence is there, and system will check where the warehouse number first 001, and what is the storage type indicator. If say for example if it is C01, say for cosmetic material, and then it will go for the first storage type defined against that. And if the material is not there is available or not available, it will go for second storage type and a third storage type and then fourth storage type. Like that we can able to define 30 storage type within this storage type search sequence table. Okay, in this can be done in pro screen. And next thing actually once the storage type indicator is determined, it will go for it identifies the storage type now. And next thing it will check for storage section it will check for storage section indicator. So in storage section indicator, we have defined the storage section indicator is defined already in material master. So in material master, the indicator which is defined in the material master can be taken as a reference, and it will go to the storage section search sequence criteria screen. And against the warehouse and storage type, we need to define the storage section indicator. And against that, we are grouping the maximum of 10 storage section in standard SAP. We can able to group 10 storage sections in sequence under below the storage section indicator. Say for example, our storage section indicator is C01 for cosmetic. Same like our storage type indicator, we are having the same C01 as a storage section indicator. So the system will check once it determine the okay 001 warehouse, and then storage type is say for example 001, and then actually the storage section indicator is for example C01, and below that we have the define we have the maximum limit of 10, defining the 10 storage section. So it will check for the first storage section, and if material is not there, it will go for second and third, like that up to 10. I hope actually now you can understand the maximum limit for storage section is 10. Then we can define 10 storage section, yeah, below the storage section indicator. The same way in storage type, we have maximum limit of 30 storage types can be defined, can be grouped under the storage section indicator. Now we have we have identified the storage section, and next comes the storage unit. If it is storage unit management is activated, we have the storage unit unit type indicators defined, and the same way like a storage type and storage section, we can able to group I mean, say for example 10 to maximum of 30 storage unit type storage unit types below the storage unit type indicators. And then we have the storage unit type, all the operations are same. So here actually the storage unit indicator, the section indicator, storage unit type, and then bin indicators, and then finally the block of bulk storage indicators, everything can be interlinked by using assignments. Okay. So now actually the final now we have defined the system checker the metal master indicators in Varos one view, and then actually it has checked that storage type indicator, section indicator, storage unit type indicator, and then storage bin type indicators, and the final will be bin indicators. Then actually it has determined the sequence, that is storage type search sequence, storage section sequence, storage unit type or bin search sequence, everything. And final point will be the strategies. So whether if it is for put away, it is a put away strategies, and if it is picking, then it is a picking strategy. In below the strategies node only in SPRO, we have this: activate the storage shape search, activate the storage section search, activate the storage bin type search, whatever I have explained in detail. So this is the point where this is a screen where we are defining all the such searches. And then fourth will be the defining the sort sequence for put away. So in what sorting, mean what order, say 1 2 3 like that. So for put away, and define sort sequence for stock removal. So this is the sequence for which the storage type or storage section to be checked by the system. So these are defined here. And then actually as a sixth point, we need to define the put away strategies. Okay, we have different put away strategies in SAP WM. So the first one is define strategies for fixed bins, and then we have open storage bins, and then third will be the addition to existing stock, and fourth will be empty storage bin. Then we have strategies for pallets, and then bulk storage, and then we have near picking bin, and also the customized uh, put away strategies are allowed. And we have the user exit in storage type control screen. Actually there you can combine two different searches, I mean strategies, I mean put away strategies or picking strategies, and we can be able to group together. For example, in case of food industry or chemical industry or pharma industry, we can able all the put away and picking can be worked based on the first in first out and a shelf life expiration date defined. Because for any chemical we have the expiration date and best before date for the end customer. So actually this is to be considered very efficiently. So actually these two strategies can be combined. So based on the expiry date, that particular material can be taken out for picking and sent for shipment and delivered to end customer. So we have the user exit to combine two different strategies to work efficiently. This is also possible in SAP WM. And then actually we need to define the strategies for stock removal. So in stock removal, in the sense we have first in first out, last in first out LIFO, first in first out PIFO, and then stringent FIFO. Stringent FIFO is just an opposite to our LIFO. And then actually partial pallet quantities first, that strategy. And then either the quantity is large or small quantity, the system will determine the large quantity first or small quantity first, based on the business requirement we are configuring. And then shelf life expiration date and fixed bin stock removal strategies and returns transfer, say stock returns. So all these things are able to define in stock removal strategies. So actually we are, I mean, how the strategies can be chosen, chosen while doing put away and picking. It is done through it is decided by the business requirement and the top level management in a client location. They will decide whether we need to go for fixed bin or not. Say for example, if you're defining a fixed bin, then you should define the storage bin, fixed storage bin in material master in plant or storage location view. Then as your say in case of barrows WM and view in material master, so that system will check that particular fixed bin. It won't go for any I mean uh, the search sequence or indicators search. Nothing is there. Actually, directly it will manually you can place that particular bin in fixed bin. So that is important thing. Directly that bin will be considered for put away. Okay, or say for example picking. And open storage for in case of actually like a coal heap or kind of some oil, some some toxic materials can be placed in open storage location, can be maintained in ambient temperature like that. Actually, in that case, actually, don't want to segregate the material or store the material in different bins. We can treat it as a open storage. So that is very simple, right? Actually, there is no tracking of material is required. We can able to track the exact quantity using the LS24 thing or something. Then there is no report is required here for open storage. Addition to existing stock, say system will allow for addition of existing stock for the same kind of material, whether we can have able to add the new material for the existing stock. So in case this is for say for example, if you are doing refill or replenishment, this is very important. And empty storage means actually your system will only place the material in empty storage bin. Which bin is empty, that bin will be that will bin will get automatically loaded with the put away material. And pallet thing, bulk storage is used for food industry, like case kind of Pepsi, Coca-Cola. Those kind of industries will use the bulk storage, because actually say for example, bulk storage will allow the mixed storage. It means actually say for example, a particular customer orders some 10 HUs of pallets of Coke and 20 pallets of Fanta. In that case, actually, we can place this, reserve this particular bin for the customer requirement, and we can mix that 10 pallets of Coke with 20 pallets of Fanta, and we can maintain that in the same storage type. And while picking, you can easily pick that particular stock from the particular bin. So this bulk storage will be more helpful for that. And say now we have the pallet to unit conversion is there. Say for example, one pallet is equal to 120 piece, like that conversion is there. So you can convert, say 10 pallet of Coke means say for example 1200 of pieces. And same like actually you can calculate for Fanta. Okay. And the first in first out, as I already told, the in pharma or medicine chemical company, first whatever the first material in coming can be taken out first, because actually we need to keep on tracking the expiration date and everything. So the first coming material can be taken out first, and last in first out is nothing but in case of construction industries, right? In case of construction industries, actually say for example, the bricks can be arranged in from bottom to top. The new bricks can be placed at the top, and the old bricks that are coming first, right, that is placed under bottom. And while picking, we cannot pick that material, the bricks under the bottom, because everything will get damaged and it will fallen. So we need to take the brick that is coming at later stage, that is last stage, that will be picked first from the for the first pick. So like that, actually it will go from top to bottom. So that is considered as a LIFO. Stringent LIFO is nothing but just opposite to the LIFO and all. and then partial pallet quantity. So say for example in barrows, actually the barrows manager or your user, they don't want to pick the particular material from the full material. They need to first complete, or they need to first utilize the partial pallet quantity bin first, and once it is emptied, then they will go for next bin. This is nothing, this is to avoid the confusion, because here in bin 1 actually we have 50, and in next bin we have 1000. Means actually if you pick from 1000 quantity, then actually the first bin will have 50, and again the refill will be problem. So first we need to complete the quantity from the partial pallet bin quantity, and then it will get then we will move to the second bin having 1000 quantity. And same like large quantity or small quantities difference, right? That will be considered as a important thing in case of picking selection. Say if the bin is having large material first, then actually we need to uh, pick the large quantities first, and then actually the small quantities can be taken at a later stage, or vice versa. And then shelf life expiration date, already I told. Actually shelf life expiration based on for the pharma and the thing based on the expiry date and all. And fixed bin means the from the fixed bin, if you define fixed bin in material master, from that bin only the particular x material will get picked. It won't go for searching of it won't go for search of indicators sequence and all, and nothing will happen. Directly it will go directly to fixed bin and pick that, and it will issue that material to for picking location. And return transfers, I had told. Actually this is for again actually returning the material from where the picking has been done. So the same location as in the same location we need to place the material to avoid confusion. Say for example, if the particular user is placing the particular material at a different bin, he has already taken from bin A, and actually he is placing in bin B, then actually it's a problem. Actually while tracking of inventory or tracking for or doing for the next successive pick, automatically the warehouse the one another shift person cannot know. So if it is returned to the same storage bin, then it will be very good, and he can know the what is the exact transaction has been happened, what is the material movement, why return has been done. Everything can be recorded. That will be optimized or efficient way of controlling the material movements in a warehouse. Okay, and now we have done with the strategies. First is master data, and then actually we have defined that indicators, search sequence, then strategies, and then actually I mean, in strategies below that we have stock removal and stock placement strategies. Now we have assorted material, um, uh, assorted material management definition. We here also we need to define the master data, whether that whether that material is really assorted and what condition to be maintained. And we have the indicator called assorted material indicator maintained in the material master. And then once everything done, we have defined fire contaminated sections. So whether this material is prone to fire contaminant or not, so these are the master data to be required in maintaining the assorted material management. And then actually system will we have the option to check whether the particular material requires assorted material warning while doing PGA or PGR or material movements in between the two different material movement between the bins or something. The system, if you set this assorted material warning, then it will issue the assorted material warning while doing the processing the delivery. And then actually we I mean might be during the TO creation or delivery creation or saving that confirmation everything. And then define assorted material storage warning. And so whether the storage should consider the assorted material warning or not. First we need to define for material, and then define the assorted material for the storage warning. And then we need to define the aggregate state. So the aggregate states in the sense, actually the assorted material will undergo different levels of stages. Say for example, first it will go for our some treatment, chemical treatment, then physical treatment, and then actually some different states will get continuous state change. So depends on the state, different states it is undergoing change. We need to define the storage as per that material requirement, as what as material requirement factor is there. So we need to define the aggregate states, should be aggregate of all the states for the particular material, as what as material. And then region codes is nothing but whether this region is belong to Germany or India or France or say for example US or something. So based on that, the assorted material handling can be will vary. Say for example, if it is India, it is a hot prone area. So I mean certain precautions to be made. And if it is Germany, it is very cool, so we need some precautions to be maintained for the particular assorted material. So depends on that, we can the area, geography area and regional areas, we can uh, treat the material as per the storage requirement is considered. Then storage class, the storage class is nothing but it's a say for example, it is a country based code. Country mean the government or import or export the, say for example, the commerce ministry, they are giving codes based on the standards. Say for European Union, some codes for the same X material, and same for the same say X material in US have, they are having different. Say same for a same X material in South America, they are having, in Asia different, in Africa different. So the storage class is nothing but like our IP address 132 dot say 192.68.000 like that. So the dots will different will separate the codes. So that will use it for the identification of the material from where it is coming and everything. And then actually we need to define the strategies for the assorted material. That is much more important. So which strategy should be um, considered. And then actually we need to define as a final thing, we are in strategies below that, we need to define activities at assorted material management and everything. So now we defined master data, then the strategies and assorted materials, and finally, I mean, as a fourth point, actually, we need to define activities. Activities in the sense how the transfer TR is created, how the TR should get converted to TO. What is a shipment type? What is a requirement type? What is a movement type involved? So what is the exact defined stock term? What is the exact stock transfer required and replenishment control required? Whether replenishment control is required or not. So and also the automatic TO or TO, immediate confirmation for the TR or post change notice required or not. Setting up two-step picking for the TRs, this is much more important. And then processing performance data for TO split. So why you are splitting the TO means, actually say if bulk means the time involved in processing the particular order will be taken more time. So if you split the TO, the first partial thing will get processed faster, and it is sent to the customer, and second thing will get processed like a batch kind of thing, actually first one, second one, third one. So we are splitting the TO based on some sequence, say some 10 quantities first, and then 10, next remaining 10 quantities in next thing, and from 21 to 30 line item in third one, like that we are splitting the TV. And then confirmation. So finally we will define that print control. So all these things are defined here. And so this requirement types and shipment types and movement types, actually I can say actually it depends on the material, depends on the business requirement, and as per the material requirement everything is considered. So here the I like to tell one important thing, the here the defined movement types. So normally, I mean the people will ask, actually if any WM movement type has been made, how it will get intimated to inventory management movement type, movement type. So this is a very good question, and it is answered you by actually this the IM, that is MMIM movement type will be linked to WM movement type using an reference movement type defined in the SPRO configuration under movement type definition. Say for example, if IM movement is 101 and WM movement is 101, and it this both movement types can be linked through reference movement type. And if IM movement type is 102, the WM movement type will be 102. And if IM movement type is 103, and the WM movement type will be 999. If 999, there is no action will be taken place at the WM level. This is very important. And other than 999, then the particular action based on the movement type will take place. And for movement type 104 in IM, the corresponding WM movement type is 999 like that. And if in movement type 105 in IM, the corresponding will be WM movement type will be 101 if action is required, or we can define 999 if no action is required. This is again depends on the business scenario and user requirement considered whether to choose 101. 101 means IM movement if happen, then corresponding WM movement will happen, or WM movement happen, then corresponding IM movement will get updated. And if you are using WM movement 9999, then actually there is no corresponding IM movement, and if IM movement happen in the WM, there will be no movement or no impact in it. So that is, so we are using 999 like that. And for example, movement type 106 in IM, the reference W movement type will be 102 or 999. And for example, reference movement type in IM movement type in 107, the equivalent movement type will be 101 or 999. And the same way, actually for IM movement type 108, uh, the equivalent WM movement type we are defining is 102 or 999 like that. And the same way for IM movement type 109, 109, we are having the reference movement type 9999 like that. And same for returns movement 161 in IM or materials management movement, we have the equivalent movement 9999 in WM. Because why? Because actually we are not having any accounting hit or any accounting entries in case of WM is required. This is considered very important. And say for example, the stock transfer and replenishment control, I like to say. So this stock transfer and replenishment control is more impacted in case of WM. So replenishment control is nothing but if a particular stock is taken from particular storage bin, you should say the empty storage bin can be immediately refilled. That is called replenishment control or not. So if it is refilled automatically, it would be considered for the next pick, stock pick or no, stock pick. And this is very important. Actually, we need to properly maintain the stock at the bin levels for inventory tracking. So then actually set up automatic PO creation for TRs and post change notice. Automatic PO creation means actually once you create a TR or post change notice, automatically automatic TO creation in background will be taken place, and confirmation also we can do. And this automatic conversion of TR to TO or from post change notice to TO, everything can be done through a background job scheduling. For TR to TO automatic, this one automatic conversion, we are using the job RL UAT10. And for post change notice to TO creation, we are having automatic job RL UAT11. This is scheduled by the basis in SM 36, and then actually schedule in SM37. They need to schedule the job at the frequency level. And this TR to TO conversion can be taken at the end of the shift. Say for example, particular user is working on from morning 6 to 2. At the end of by 1 o'clock he need to convert everything, all the TR to TO. Then automatically he need to, when the job will be scheduled at 1 o'clock. And similar way, when the shift starts in the afternoon from 2 to it ends with the 10, at 9 o'clock the job should be scheduled, so that automatically the TR from TR created can be converted to TO. And for post change notice, all the post change notice document created can be converted to a TO. This is very important. And then actually we have set up two-step picking for TRs. Say for example, in case of big industry or some, in some frequently say actually mass processing industries, actually we cannot every time actually we can create a TR and then we can create a TO immediately. That is not at all possible, and it is a time consuming issue. And whereas the user cannot find time in other, if he is doing TR to TO conversion very frequently, he cannot able to concentrate on real day-to-day warehouse activities. So for that, actually what we are doing, we are able to create a we are able to create a TO and then convert the TO, and it can be linked, all the TOs can be linked to a group or a wave. So using LT41 transaction, we can able, with reference to the group, we can able to convert the we can able to confirm the group, so that all the listed transfer orders listed below that group can be confirmed, and a single shot it can be processed the same way whatever I told in the shift thing, right? Actually, whether it's shift basis or it is a end of the day, or it is the end of the week, or end of the month, or 2 days once, like that, depends on the business requirement. So here actually the TOs created will be a first movement. So the material will be placed in some interior location, and once the group it is linked to a group, and in LT41 we are confirming the group, so that actually the TO is confirmed. So in background, yeah, all the that materials in interior location will be transferred to the destination location of interest, say, or shipping location, shipping location for deliveries. Okay, and then confirmation, same thing, confirmation, we need automatic TO confirmation or not, or partial confirmation, full confirmation required, not everything. In under the movement types, we have the automatic TO creation, confirm automatic TO, then immediate TO creation, manual TR creation is allowed or not, automatic TO creation is allowed or not, manual TR is creation is allowed or not. So capacity check, print, that is a TO print is say for example, it is a single document or a collective document, multiple document, based on the HUs, like that. We have different setup is there under the, say for example, we have storage unit management is active or not. So all these things are activated. And what is a storage bin and destination storage bin, what is a referent movement type to be used. So all these returns are I mean returns in the same bin is allowed or not. So all these things we need to define in movement types and everything. So it will determine the confirmation and all. And they say the performance data is nothing but I told the TO speed, in order to access the transfer order fastly and efficiently and very quickly, and so that the performance can be improved, and the processing of transfer order is much more simplified. So in that case, actually, we need to follow some sort sequence for put away and picking. So in put away, for example, 1 3 5 7 9 will be a sort sequence. It will go for 1 and then actually 3 and then 5 and 7 9, like that. So it will go, the sort sequence will go in sequence, and the same way that sort sequence can be defined in LS0 to N. And below that, actually, we have this sort sequence for put away and picking. One field is there you are defining all this sort sequence, so that actually the performance of the transfer order handling and everything, the material picking and everything put away can be optimized, and it is processed faster. That is important thing. And next comes, we have the defining print control. So defining print control, actually here, actually it is not same like our standard purchase order printer I mean purchase order goods receipt printing, right? Actually it is defined, it is I mean this WM I mean print control is entirely different from our PO and uh, GR output determination. Here we need to define some certain 10 steps. As the first thing, we need to for creating the TO print output, we are using transaction LT30 LT31 for generating the PO spool, that is print spool, so that actually we are able to process the TO printout. So first step, we need to create a spool indicator for each warehouse. That's the first step. And as a second step, we need to define the printers for each label printing. Label printing here, we can make use of zebra printers. Zebra printers mean in a pedestrian, actually you can see alternate white and yellow, white and black codes, or it is a barcode. We have this different black and white codes, right? The same, that is called a zebra printer. In even in all the labels, the HUs were in the form of this alternate zebra codes, and each code will define some numeric value while doing the barcode scanner or something, actually RF scanner, that data can be scanned, and the same can be, the value can be transferred to the SAP. And then actually we have defined sorting profile for multiple processing. So for multiple processing we need to define a sorting thing, because it normally occupies different groups of orders. We need to define which order to be defined first. So for that we need some profile, so that profile will have some certain sequence, sort sequence. So that is important. And then actually we need to define print code for each warehouse number. So we need to create a one print code for each warehouse number, and then assigning the printers to the individual movements. So for each individual movement, say for 101, if we need printout or not, we need to define that say configuration to the the printer, so that actually once 101 is posted, the spool will get generated and we can get the printout. For that we need to assign one printer, and then assigning the printer to picking areas. Okay, first we are defining individual, assigning the printer to individual movements, and the second thing we are defining the printer to the picking areas, and the third thing assigning the printer to storage types. Individual movements, picking areas, storage types, and finally assigning the print codes to the movement types. Okay, these are very important thing, as a sequence of action is required. And assigning then actually as a ninth step, assigning the assign print reports to the warehouse numbers. Okay, and this is much more important. And then actually as a final step, we need to assign the print control to multiple processing runs, so whether it requires multiple processing runs or not, so those things should be defined here. And uh, and actually finally we need to make use of analysis programs, actually, that will define actually whether the print can be done properly or not. So those things actually we need to ensure. So this print analysis program will verify the setup is perfectly configured or not, or any mistakes is there, so that those things will get determined. And the print programs we have, for general print program we are using RLV SDR40. Okay, and for multiple processing we are using RLK OMM40. Okay, these are very important thing. And for the each print program we are having the user exit. See, for general print program we are having MLM D0001, and same for multiple processing we are having MWM D000, that is 302. So we can able to develop a customized program also. Whatever I told, this is a standard SAP program given by SAP. Okay, and then we are defining the physical inventory. Say actually in barrows, actually we are having different types of say for example different types of physical inventory methods are there: cyclic counting, and then actually annual physical cycle annual inventory, and then actually normal general normal inventory, or periodic inventory. Different types are there. And in standard, for doing any automation thing, we need to go for automatic, that is cyclic counting, dynamic cyclic counting. The physical inventory is adopted. And actually in that, actually we are classifying the materials based on three indicators, that is cyclic counting indicator A is nothing but actually frequently used high important material, and cyclic counting indicator B refers medium importance and mediumly used materials, and that is frequency is medium. And category C, that is cyclic counting indicator C, it is nothing but very unimportant and very means solely used, not frequently used materials. So based on this, materials can be classified into three categories, and these indicators are defined in say plan per storage location view of a material master. In that, actually whether the material is subjected to cyclic counting or not. So see, cyclic counting is not checkbox is there. If you check that automatically, cyclic counting indicator what is A, B, C or there. So those to be defined. And in configuration that is below dynamic cyclic counting indicator configuration in SPRO, actually we need to define the general setting, and below that actually we have this what is a warehouse, what is a particular indicator to be used, and what is the frequency of cyclic counting, what is the duration of cyclic counting, and what is the exact period of that, and everything should be remain, and each is given rating, and based on the rating it is determined. So actually during the stock taking during the annual the end of the year end, or it is a month end, actually user can automatically trigger the cyclic counting indicator, cyclic counting process using the background programs using reports and all. They will generate a physical inventory documents, and they will post the difference based on the company principles, mean company policies and the methods they are using. This is a cyclic counting method of physical inventory. And we have the annual physical inventories there. So we have a transaction LX46, LX47. Those transactions will trigger the cyclic counting. And also one important thing, actually we can define this physical inventory with respect to particular storage type. Say for example, for the particular storage, only one storage type we can trigger the plan or trigger the cyclic counting, I mean physical inventory. So that is also possible, not required for for doing completely all storage type. Only one storage type if you plan, then you can do for that particular thing. Say for example, in during your last run, one particular storage type is subjected to some maintenance or something. The bin within that actually having some issues, physical damages, or some corrosive erodive action in some acids or chemicals is maintained that metal structure get spoiled or damage. So it is subjected to maintenance during the last run. So in that case, actually that particular storage state can be considered for the next physical inventory, avoiding the next other storage types. This is also possible. And here actually in below this physical inventory node, we have different options, that is default values. We need to define the default values, and we need to define the, and that is I told right, actually what types of storage, I mean physical inventory type for storage type. So we can say for some 001 we can define cyclic counting, 002 annual physical inventory, like that. What type of different types of cyclic, I mean the physical inventory methods can be applied to different storage type. We don't want, there is no compulsion of using same physical inventory method, cyclic or cyclic counting or annual physical inventory or whatever it may be, to all the storage type. It is not it's not a mandatory thing, or it is not recommended. We can use different methods for different storage type. That is very important. And second thing, we need to third thing, we need to define the difference and the document list. So how the difference will be handled, and how the difference in the IM and WM moments can be offset. So what is the transaction involved, whether it is LI20 and LI21 can be used, and what is the, if you use LI20 and LI21, what is the movement type used, that is 711 and 712. Bear in mind, actually 711 and 712 will be an offsetting movement types for the physical inventory in WM. In same way, for MM, we have 701 and 702, which offsets the difference and nullifies the entry, book entry, and the actual physical cycle, actual physical inventory count. So that difference will become zero using this movement type. And how the clearance, that is physical inventory clearance, can be done is any interface to the cyclic counting mean interface to IM, which updates the WM cyclic counting results, clearing differences, any difference clearance is required, and that should get interface to IM. Because actually when I worked in say for EMC project, actually I see actually the third party cyclic counting software is integrated with SAP, and in that actually what are all the difference between the IM and WM movements can be cleared to, and it is sent to the through interface to the external that cyclic counting software, that will offset the entries between the book entries, that will clear the difference between the book entries and the actual physical cycling counting without depending on I mean with completely depending on SAP. If, third-party tools are also available from for some clients, and then we need to maintain the number ranges for the physical inventory. That is more required. So this is the number ranges normally done at the year end. Okay, that is very important. And then dynamic cyclic counting I already told. So avoid we can avoid explaining again once again. And then as a next topic, actually we have storage unit management is there. If storage unit management is there, then we need to define master data for the storage unit management, and then actually we need to activate the storage unit for the warehouse number. So this can be defined at the characteristics of warehouse parameters, right? In starting of WM configuration, under master data we have this option, and second option will be in storage type control definitions, and then third will be in movement types and everything. We have the three levels of storage unit management activation is there. And then we need to define ID point transaction. Say for example, same like HU movement tracking in RFID RFID transactions we have in case of say uh, storage unit management is activated. We have the ID point locations are there. In that is some sensor is fixed, and if the materials are moved in and around that conveyors, actually conveyor belts, actually that ID point transaction will track the material by using the SU label pasted in the that box storage unit. So it will track how many times that a particular material can be can pass or it will cross that particular ID point. Based on that, they can be able to determine how much frequency, how much importance for that particular material, what is the exact customer response for the material, whether it is reaching the exact expectation of the material usage and the deliveries, everything, material handling, everything, and efficiency of the operator, efficiency of the warehouse, everything can be calculated, and which in turn indirectly hit the returns on investment or inventory cost or whatever story financial thing also we can calculate. That is for that only ID transaction is required, and this is defined at a storage type control. Below that, whether we need a storage type ICUT ID point is defined or not, so that field is there. We need to input that if we required ID point. And then even for storage unit type, storage unit management, we have the print control is there, same like our standard WM process. So one important thing here I like to tell, um, normally storage unit management will be coming by default with SAP WM, whereas the handling unit management we need to configure, we need to activate in below that SPRO. And in logistic general we have the handling unit management activation with for the IM, WM, PPSD and also we have the storage location based, handling unit based storage location activation node also available against each plant and storage location combination. Below the logistic general handling unit management, and below that inventory management, defining HU for the inventory management. So in that we have this plant per storage location combination activated with HU requirement for the partner also. Even when the partner location also we need to define. This is very important in case of handling unit management is activated in the WM. And normally in normal standard WM, one HSU is equal to one HU. This is the standard conversion factor. We can able to set 1 is to 2 also, but in default 1 is to 1 is accepted. Okay, and we can able to use WM without HU also, but normally SU will be coming in default. And if you are not activating the SU, then actually it is pure WM. That the operation of the TO creation and confirmation is very easy. And if you are activating the HU, then the transaction is, WM transaction is very problematic, because actually if any partial or if any user has did lot of transactional movement mistake, or if from particular TO is not properly confirmed, then we cannot able to reverse the HU activated with the WM. in WMHU location. It is very difficult, and we need to go for alternative step by moving the stock to some other location, and then actually we need to process. Or if nothing is possible, say, yeah, if totally corrupted in WM quantity or IM quantity, anything, then we need to go for SAP to get it corrected. We can able to correct that using reports, if not possible with possible from our side, from support IT side. Okay, and normal strategy defined for the storage unit is always bulk storage area. This is very important thing we need to consider. And the next thing actually, I like to discuss about interfaces. We have integration point with integration point of WM with IM, and then with QM, and with SD, and then with PP. And in case of say integration point of WM with IM is for uh, by defining the storage location control, and then defining the movement types already explained, and defining the posting changes, and then generate the interior storage bins, right, from 900 to 909. We have for the storage type, we have the storage bins to get generated, and then automatic TO creation, allow negative stocks, allow negative stocks for the interior storage. Even for interior storage, we need to consider whether we need to consider or not, whether to allow or disallow the negative stocks. So that should be defined in the IMWM interfaces. And then goods movement IM not allowed for the storage types. Okay, goods movement IM not allowed for the storage type. This is very important. And below the shipping, we have this shipping, defining the shipping point control, and the two-step picking, right? Actually, the picking can be taken and achieved in two steps. First, we need to create a assign a TO to the group, and confirming the TO in second step. So that one. And interface of WM with PP is for Kanban, and WM as the control cycle, where PP and WM are closely integrated. We need to define, activate the WM PP switch for that, and also production supply area we need to define. So these are the important, very important thing. Actually, we need to, this is nothing but WMPP control cycle is nothing but we are say for example, we are integrating WM and PP. Say for instead of doing manual 260 movement to issue the goods to the production area from warehouse raw material, we are automatically issuing the material by creating one PSA, and that is PSA is linked to a shop floor. So the material will be placed from warehouse to the PSA, and from if many material requirement is required for the shop floor, that materials are issued from production supply area, and once it is converted as a finished goods product, it will be issued back to the production department. And once the quality department certifies that particular production of material is good, then it will be placed after releasing the usage decision in QA32, it will be placed in the unrestricted. So this is an automatic movement type is occurring. We need to consider 319 and 101 movement type for cyclic counting. The Kanban also same. In Kanban we have lot of automatic goods receipt and goods issue. We have this Kanban indicator is there, so automatic refill, everything is taking place. So the Kanban configuration is closely linked with say for example PP. So say for example, um, the Kanban is Kanban is mainly used in Toyota, actually in Japan. So actually the material issue and material receipt can be processed very faster. So then actually next comes QM. In QM, as I already told, actually once a material raw material or finished goods coming from the vendor, when while before receiving in unrestricted storage area, we need to go for quality check, and we need to create a quality plan, quality usage decision, everything. And if any defect, we need to enter the defect and reject that, and if it is material is okay for during the quality inspection, then it is accepted, and digital segment is verified, and then the material will be moved from the quality inspection to unrestricted area and placed in the final storage bin. So here is a one point. And second quality check is done at finished goods coming from the shop floor of the in-house production. So once the finished good is converted, the quality department will check for the quality and whatever criteria they are expecting. If it is okay, they will release from quality and place it in unrestricted area. So this is the one thing. And then actually we have task and resource management are there. And here the task is nothing but, say for example, picking or put away or moving from one bin to another bin. These are the tasks, internal WM movements or external WM movements, receiving, put away, picking. And resource is nothing but the man or machine who is helping the to perform the task, either a man or a machine. So we can able to track which material, say for example, machine in the sense forklift or convey, overhead conveyors, or it is a automatic guided vehicles, carousels, ASRS, whatever it may be, it's a machine. And a man means actually a human being. Normally literally is a human being who is involved in doing the particular creative or creation, confirmation, and addition of assigning the HU to the particular material, packing material, so consolidation, deconsolidation, oh these are all the tasks. So this is nothing but managing the task and resource, using the, they were combining the task and resource, who is performing the task, that is a resource. So that is called TRM. And external, and finally we have this external integration of warehouse management to the this forklift, then carousels, and then external control systems through ALE or warehouse control systems, WCS. So through IDOC also. By ALE means we have different types of IDOC. Say for example, when a TO is automatically read and sent to the external system, we need to use WMTO RD, WMTO read. So that WM TOD, that will be an signal from the SAP to outside system. And once that particular HU, that handling units can be read, sent to the external system can be read, they will send WMTO confirmation TOCO. And if any problem in damage or any mismatch of HU or missing of HU, then they will cancel the TO. That signal will be sent through an IDOC called WM WMCATO. That is a WM transporter cancellation. And if it is confirmed, WM TOCO, TOCO, WM TOCO, that is the IDOC we are using. Through that, actually, the SAP WM can communicate with the external hardware or external systems where the warehouse control is performed at the remote location. These are I will explain all these things in AS or a system, if how the IDOC is used, and how it is functioning. And then actually we have different transaction for listing the storage bins. Everything is there. I will explain everything in next coming WM transaction. Thanks for listening my session. In first session I have covered about what is the overview of WM, in that is inbound process, outbound process, cross-docking process, why WM is required, and what is important, how it is having advantage over the IM storage location. And in second part of video I have covered the WM configuration, how the system determines the final bin to be placed, put away, and how the system determines from where the source bin, from which source bin the material to be picked and placed and stored, where to be moved at to the final destination. So during picking, so these I have covered. And then actually storage unit management, interfaces with IM WM, integration of WM with IM, quality management, then SD with the PP, external connection of WM to external systems, that is conveyors, forklifts, and then AGVs, carousels, ASRS. And then actually defining the physical, about the physical inventory. Then we talk about the sorters material management, and what are all the WM internal activities, that is creation of TR, TO, and then what is a shipment type used, what is a movement type used, how the IM movement is linked to the WM movement type using the reference movement type, what is the automatic TO creation, how the automatic TO confirmation happened, what is the two-step picking, what is a immediate TO creation, and then what is meant by the confirmation, print controls, how the output. Yeah, how the WM print control is different from the IM, that is POGR output determination. Here we are not defining any output determination or conditions. Everything is configuration. If we are doing that output that is WM print control using OMLV transaction. So how it is done? So how the where the printer is assigned to each storage types, movement types, SUTs, everything. So I think actually it is a combined, or it is a aggregated information I like to share. In next coming videos, I will definitely share more information. I hope that is really useful for each and everyone. Thanks for listening my second part of video. Thanks. This is Shivakkumar signing off. Thank you.